So example 19 in the Aurora, SL Aurora, example 19, a 30 kg shell, okay, a 30 kg shell is flying at the rate of 48 meter per second, and when it explodes, its one part is 18 kg and it stops. So a 30 kg shell is actually exploding. One is an 18 kg shell which just explodes and then stops, which means its final velocity becomes 0, while the remaining part still continues to fly. Which how many kgs is it? It's 12 kg is still continuing to fly. Move. Find the velocity of the later. By conservation of momentum, the initial momentum should be equal to the final momentum. The initial momentum, let's consider this to be capital M. And the initial velocity, let's consider it to be u. Because it's already moving with a 40. It's not stationary. This was already moving, and so then it's 30 into capital M into u. Should be this initial momentum, which should have been equal to the final momentum, which is m1. The first body's mass is 18 kg, but the velocity 0. But let's consider m1 v1 plus m2 v2, which is m2 and v velocity is v2. I'm sorry, m2 and v2. So, but you know that v1 is already 0, so this can be ignored even if you put 18 here. And m2 is nothing but 12, and they are asking you to find this velocity. This is 30. And this is 48 meter per second, and so then you can take multiply this and take the 18 to the other side, and so you will get the value for velocity v2 to be 30 into 48 by 12, and the value is 120 meter per second. And so, but this is based on conservation of momentum. Very, very important. Initial momentum should be equal to final momentum. Let's go to 20th question. A neutron having a mass of 1.67 into 10 to the power minus 27 kg and moving at a speed of 10 to the power 8 meter per second collides with a deuteron. A neutron is colliding with a deuteron. A deuteron is a hydrogen H12. Okay, that's the isotope of hydrogen. A deuteron rest and collides with a deuteron at rest. So the initial velocity of the deuteron was 0 meter per second, but this has got initial velocity. They both are colliding. Those are the initial velocities. One has got 10 to the power 8 meter per second, other has got 0 meter per second, and the mass of the neutron has been given, and they are saying it's colliding with a deuteron and sticks to it. But so when after colliding, this mass m1, that is the neutron, and the deuterium or a deuteron is going to be sticking to one another. If the mass of the deuteron's mass is also given, it's 3.34 into 10 to the power minus 27 kg. Find the speed of the combination. So these two are going to stick together and then move. Okay, so the initial velocity, initially what's happening, this is the initial velocity. Do you know mass and the velocities? Let's write the initial momentum, which is m1 u1 plus m2 u2. m1 is 1.67 into 10 to the power minus 27 into its velocity is 10 to the power 8 plus m2 is 3.34 into 10 to the power minus 27 into its velocity is 0. So this goes away. That's the sum of the initial momentum, okay, which will be equal to the final momentum. The final momentum has got both the masses together, which is small m plus capital M, or m1 plus the mass of this and the mass of this together, which is 1.67 into 10 to the power minus 27 plus 3.34 into 10 to the power minus 27, because both of them are moving together with an unknown velocity v. You don't know that. So you're going to find this. You just add these two. In this 10 to the power minus 27 is common. You can add this and this, and you can write your value, which is which will be 5.01. 5.01 is 7 plus 4, and this is so it's 5.01 into 10 to the power minus 27, and into v is equal to 1.67 into 10 to the power minus 27 into 10 to the power 8, where the 10 to the power minus 27 get cancelled. So v itself is 1.67 into 10 to the power 8 by 5.01, whose value is 0.333 into 10 to the power 8 meter per second. Again, using conservation of momentum. This principle is very, very important. 21st question. A car of mass 1000 kg. So there's a car of mass 1000 kg traveling at the speed of 32 kilometer per hour. Kilometer per second, okay. Meter per second or kilometer per second? Meter per second, sorry. 32 meter per second dashes into a rear of a truck. Okay, so this is going to dash on the rear of a bigger truck. And the mass of this is 8,000 kg. The rear end is this, the driver sits here, that's what is called rear end. Moving in the same direction, so they both are moving in the same direction. This is moving at the velocity of 4 meter per second, but as this is moving with the initial velocity 32 meter per second. Okay. So after the collision, the car bounces with the velocity. Obviously, it will go and car will get rebound. So it's going to bounce back with the velocity of, it's going to bounce back, I assume, with the velocity of 8 meter per second. The car is going to dash on this, it's going to come back. What will be the velocity of the truck after the impact? So then, after the collision, they have given one of this mass 1's velocity, V1. And they're asking you to find the mass M2's velocity after the collision. Okay, so that's the V2 is the question. And let's write conservation of momentum, which is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. And the m1 is the first mass, it's 1000, into its velocity is 32, plus m2 is the second one's mass, which is 8000, the velocity is 4, is equal to, what are the final velocities? M1 is again 1000, and that's going with the velocity of 8, but you have to write it as minus 8 because it's going to only rebound. So plus m2 is what is the velocity? 8000, but you don't know the final velocity v2. So now you can just multiply these two. You can take out common in this. You can take it common and okay, when you solve this, let me write it, you get this to be 8 4s are 32 000 plus this will be 8 4s are 32 and this is also 32 000, which totally works out to 64,000, and this minus 8,000 comes this side and goes as plus 8,000 is equal to 8,000 V2. So in adding these two you get 72,000 is equal to 8,000 into V2. 9 8s are 72. So that, and you understand that it's positive. Given that you got a positive value, you understand that the 8,000 kg truck is moving in the same direction as to how it had actually started. It's going to move with a greater velocity, but in the same direction. So that's the key. So again, I'm using conservation of momentum. This conservation of momentum concept is very, very important. A hunter has a machine gun. So you're talking about a machine gun which can fire 50 grams bullet. Each bullet is 50 grams with a velocity of 500 meter per second. A 40 kg trigger springs at him with a velocity of 10 meter per second. You all know that when the bullet is fired, comes out, there is equal and opposite reaction. The gun also moves backward. That's the reason the machine gun are always placed on the shoulders of the army men. They will place it on the shoulder and they will shoot, because when they recoil, when after the bullet ejects out, there is an equal and opposite reaction due to which it can damage his shoulder if he is not going to place it in contact. And also the mass of the gun plus the mass of the man here is getting added together. The mass is more, the velocity with which it's recoiling will be less. So these are the things that I've already told you in the class. So now coming back to this question, a hunter has a machine gun that can fire 50 grams. That can fire 50 grams bullet. These are bullets, okay? I just don't misunderstand 0.5. So let me draw the bullets in red color. So many bullets are going to come out. Each bullet is 50 grams. They're talking about one bullet because the machine gun, obviously number of bullets will come out. 40 kg trigger springs at him. So 40 kg trigger, the trigger is going to come back to him. This is a 40 kg trigger, which is going to come back to him with a velocity of 10 meter per second. Okay, 10 meter per second. How many bullets must the hunter fire into the trigger in order to stop him in track? How many bullets? Okay, which means he should not fall off. Due to this, he should not fall off. Stop him on the track, he should remain stationary. That's what it means. You know that the 40 kg trigger, okay. A hunter has a machine gun, a 40 kg string is strict setup. Okay, now let's go to this question. Let's go to this solution. Initial momentum should be equal to final momentum. The magnitude of the momentum of n bullets. So consider that there are n bullets. Okay, if there are n bullets, the momentum is n into small m into small v or whatever. So let's refer the bullet's velocity to small only, and what do you call the trigger velocity to be capital M. So capital M into V, the velocity with which it's recoiling should be equal to n into small m into V. So if they ask you small n, it's number of bullets that comes out, it's like this. Capital M, it's 40 into, actually we are supposed to write capital M including the mass of the army men, because that they're going to serve as one unit along with the gun, but here there is no mass of the man given, so you can ignore. 40 into velocity with which is going to hit him back is 10 by the mass of the bullet is 50 grams, which is 0.05. 50 grams is 50 into 10 to the power minus 3 kg. So 0.05 into the velocity, which is 500. So then you get therefore number of, actually you will think, it's going to recall, shouldn't I put the velocity to be in this velocity to be negative, because it's about the trigger which is going to spring back at him. So shouldn't it be minus? Yeah, but the number of bullets cannot be negative, so then therefore you can take the magnitudes of it 16. So let's go to the 23rd question. A body of mass 1 kg initially at rest, which means this mass has got initial velocity to be 0. So the initial momentum itself is equal to 0. That's the most important point. Now it's going to explode and break in the ratio 1:1:3 at the masses, and the two equal masses, that's 1 and 1, which means the 1 kg is getting broken down. 1:1:3, it's 1 by 1 plus 1, 2, 2 plus 3 is for ratio proportion. It's 1 by 5 of 1 kg, and this will be 1 by 5 of 1 kg, total kg. This will be 3 by 5 of 1 kg. So it will be 1 by 5 kg, 1 by 5 kg and a 3 by 5 kg. They have given that whenever they give you ratios like this, you should consider the ratio proportion that you learnt in smaller classes. Add it and write 1 by 5 of the 1 by total of the total kg. 1 by the total of the ratios into total kg. By 3 by total of the ratios into total kg, which is 1 kg here. So it is going to explode, and the two equal masses are flying perpendicular to each other, which is this 1 by 5 kg mass and this 1 by 5 kg mass is going to fly perpendicular to each other, this angle being 90 degree. What will be the velocity of the heavier fragment? Obviously this 3 by 5 kg, you should understand how it will fly. See, the resultant of these two fragments, equal fragments, will be in this direction. Since the resultant is in this direction, since the final momentum has to be 0, you can assume that the third fragment of 3 by 5 kg will be in this direction. That is when this vector and this vector will cancel out and the net momentum will become equal to 0. So initial momentum is 1 kg mass into its velocity, which is 0, is equal to the sum of all the final momentum. The sum of this is 1 by 5 into, have they given the fragment's velocity, it's 30 meter per each with a speed of 30 meter per second, and this is also going with a speed of 30 meter per second. This unknown velocity is what they are asking. It's 1 by 5 into 30 plus 1 by 5 into 30, because if you want to see this, these are the what to say, okay, in fact you need the resultant of these two. It's like this portion, resultant you need. It's P1 square plus P2 square plus 2 P1 P2 momentum, considering this is P1 and P2, cos theta, cos 90, and cos 90 is simply 0. Therefore it's root of P1 square plus P2 square, and they both are of the same mass and same velocity, so it is 2P. Considering P1 is equal to P2, it's 2P square, and so root 2P. So root 2 into mass into velocity, 30, mass is 1 by 5 into 30 is 6 root 2. So you understand that this momentum is just 6 root 2. So I know that 6 root 2 is the momentum, resultant momentum of this, let me do it in purple color. or a thick black color, yeah, thick black color, which is resultant of this one and this one, plus the third mass, which is the 3 by 5 of the total 1 kg, which is 3 by 5 into its unknown velocity, should be equal to 0. So then it's minus 6 root 2 is equal to 3 by 5 of v. So v, therefore, can I cancel this and write minus 2 root 2 into 5. So I will get some velocity which is 5 2s are 10 root 5. And if you know root 5's value, let's see, root 5 is 2 2s are 4, 1, and put a decimal number here, and then write 4 and 42 so can I approximate it to 2.2? So into 10 is 22. That's not the answer. That's not the answer. So let's think about this once again. Let me think about this once again. 1 by 5. You know that okay, all I'm doing here is a parallelogram law. Is root of p1 square plus p2 square plus 2 p1 p2 cos 90, because angle between them cos 90 is 0 0. p1 square plus p2 square is root 2 p square, considering p1 and p2 to be the same, root 2 p. And one of the momentum itself is mass into velocity, which is 1 by 5 into 30. It says 6 root 2 to be this one, momentum kg meter per second. That has to be equal to this. Even if we consider like that, it's 3 by 5 of the unknown velocity should be equal to 6 root 2. 3 2s are 6 and v is equal to 10 root 2. I'm still getting the same answer. 10? Oh, it's 10 root 2. And root 2 is 1.414. So I'm getting 14. Yeah, the answer is right. So this is the answer, 14 meter per second. What did I do? I just equated the right resultant to the unknown momentum, and that's when everything will cancel out and it becomes 0. I have used parallelogram law here. I have used parallelogram law. When you know two vectors, you want to find this, the angle between them, it's ideal to use parallelogram law. It's very, very easy. Try to learn using parallelogram law. It becomes very, very easy. Or else you have to think of another way, which is like this is a slanting line and it will get broken down into, consider this is 45. This will be p cos 45 and this will be p sin 45, a horizontal and a vertical component. Again, this p here will get broken down to a p cos 45 and a p sin 45. And so you know that these are all final momentums only. These are all final moment, because initial momentum is anyway 0 because the initial velocity was 0. So these are all final momentums, and sum of the final momentum. So then this is going to, these two are definitely going to cancel out each other, because this up and this is down is going to cancel, the vertical and the downward component. So you have 2p cos 45. A cos 45 is 1 by root 2. 2p into 1 by root 2 is root 2p. See, you end up getting the same answer as root 2p here and root 2p here. That became this resultant here, which is same as this purple line. So it's up to you how you want to do it, whether you want to use a parallelogram. For me, parallelogram law in this case is very, very easy. So let's learn both the methods, so be very clear. Let's go to next question. So the next is it's the 24th question. A disc of mass 10 grams is kept floating horizontally by throwing 10 marbles per second against it from below. So you're throwing some marbles, 10 marbles upward, so that the 10 kg is not coming down. How will it come down? It will come down with an mg. And so then you're going to stop it by an upward force. Upward bubbles 10 marbles are thrown against it. The mass of each marble is 5 grams, which is 5 into 10 to the power minus 3 kg. Calculate the velocity with which the marbles are striking the disc. Assuming that the marbles strike the disc normally and rebound downward with the same speed. So, you know that there is a change in the momentum for the marbles. The marbles goes and comes down. And you know that the initial velocity is the velocity with which is going up is v, the velocity which is coming down is minus v or whatever. So p final minus p initial, or you can consider the initial to be negative and the final to be positive. So p final minus p initial will be mv minus of minus mv, which will be 2mv. So then you get a 2mv to be change in momentum of the marbles. Change in momentum of the marbles. So then this into how many marbles are there? There are 10 such marbles are there. So the total change in momentum is 10 into 2 mv, which is 20 mv is actually the change in momentum of all the marbles. And you're considering it per second. You're considering time to be, it's all happening per second. And so then the change in this itself can be like a force. Force is rate of change of momentum. Rate of change of momentum, we're considering time to be 1 second, so no problem. The change in momentum is 2 mv, which comes here. 20 mv it becomes because of 10 marbles. And that force will be equal to m into g, the downward force with which the disc can come down. So it's capital M, which is 10 into 10 to the power minus 3 of the disc, into 9.8 is the gravity, can be equal to this change in momentum, which is 20 mv, where m is the mass of each marble, which is 5 into 10 to the power minus 3 into an unknown velocity v. Thus you can just find what is the velocity by solving this and this and bringing it to the denominator. You get 0.98 meter per second or 98 centimeter per second. That's the answer. All of these are based just on conservation of momentum. So let's go to next kind of sums, where I'm going to talk about, first I'm going to teach you something called equilibrium of forces. Equilibrium of forces. In equilibrium of forces or equilibrium of, they say concurrent forces. Equilibrium of concurrent. What is the meaning of concurrent? Concurrent means acting at the same point. The forces are acting at the same point. You call it as concurrent. C-O-N-C-U-R-R-E-N-T, concurrent forces. So supposing there's a force F1 like this, and there's a force F2 like this. You know, resultant of F1 and F2 will be in this direction. You know, it's F1 plus F2, you know, by parallelogram law. And you know that if this has to be, this F1 and F2, this object has to be in equilibrium, there has to be another force which is F3 like this, which is equal and opposite to F1 plus F2, then the body will be in equilibrium. These are known as concurrent forces. Consider three concurrent forces, F1, F2, F3 acting on a point O of the body, as shown in the diagram. As you can see from parallelogram law, you can get F1 plus F2, and you therefore an F3 will be acting against this, so that the net force acting on the body will be 0 and the body can be in equilibrium. Body will be in equilibrium. Equilibrium means undisturbed. Okay, so that's what it is. So then you have to draw like this. You can also draw it like this also. I'll just tell you another way. The F2 can be drawn like this, and F1, as you can see, I've drawn it parallelly. F2 here and F1 here. This F3, can you see it's like this? F3 is like this. So what you could do is you can shift this F1 here, which is still parallel to this F1, and you can draw F3 like this, which is parallel to this F3, which I wanted to do, this F3 or this F3. And can you see by triangle law, F1 plus F2 plus F3 is equal to 0, and therefore we can conclude that that forces acting at the same point in the body, the forces acting at the same point in the body are called concurrent forces. When the number of forces act on the body at the same point and the net unbalanced force, you see net force becomes equal to 0, then the body is said to be in equilibrium, or the body will be in a state of rest. Okay, you can also say if the net force on it is 0, you can also say the body will be, if it is already moving in a straight line, it will continue to move in the straight line. But anyway, we will talk about the body is at rest. That makes sense for us here. So we'll say the net force acting on the body is equal to 0. This is about the equilibrium of forces, or write a note on concurrent forces. This is a diagram you should write. And let's also write about Lami's theorem. In case they ask you what is Lami's theorem, you should be aware, though we don't use Lami's theorem anywhere. We don't use Lami's theorem anywhere in numericals, because we are solving every sum as a vector only. So let's take a particle, then let's call it as, let's call these forces as, this one as F1, this one as F2, and this one as an F3, the three forces. Let's consider the angle between F2 and F3 to be alpha. F1 and F2 to be gamma, and F1 and F3 to be beta. So you consider this alpha, beta and gamma. I would say, okay, so they consider like this. And now let's convert this into triangle. So you have an F1 which is here transcended to here as F1, fine. The F2 which is here, I'll draw it like this, that's my F2. The F3 which is here, can you see this is F3, I'm going to draw it here. So I drew parallel lines and I'm able to convert into a triangle. And yeah, this is F1, this is F2, and this is this F1, F2, F3 is direction. And you know the angle between F1 and F2 is gamma. F1, F2, this is therefore gamma. F2 and F3 is alpha. F2 and F3 is alpha. And next one is F1 and F3 to be beta. So you draw like exterior angle so that you can write this to be a pi minus beta, a pi minus gamma, a pi minus alpha, 180. So then therefore now using, we can use law of sine. Law of sine is the opposite side by the sine of the opposite angle, it's A by sine A, big angle here, and B by sine B and all that, you learned it. So then what is in the opposite side? The force F1 by sine of pi minus alpha, which is in the opposite side of F1, will be equal to F2 by sine of pi minus beta plus F is equal to F3 by sine of pi minus gamma. And sine of pi minus, in mathematics you all know second quadrant, sine is only positive. All school taught your children, in the second quadrant sine is positive, and pi is even integral of 90. So F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. And this is known as Lami's theorem. But I would never use it in any of my numerical. You see, I'm going to do some example 32. You have a rope like this. Okay, actually initially you have a rope like this. And exactly midway I'm going to, a mass of 6 kg is hanging in it, a 6 kg is suspended by a rope of 2 meter, and from a ceiling a force of 50 Newton is applied in a horizontal position. So this becomes 1 meter, this becomes 1 meter, a force of 50 Newton is getting applied here. And this mass is 6 kg here, there will always be an mg which is acting down, we can say 60 Newton is acting downward. And can you see there will be a tension here which we can call it as tension T1. There will be a tension, there will be initially a tension T here, but now this is T1 and this is T2. Can you see T1 is like this? And so supposing you want to break it down into components, the T1, because it's slanting, you are considering that this is your theta, then this will be T1 cos theta and this will be T1 sin theta. And so T1 sin theta, and you see this will be equal to this, left will be equal to right. So you get the statement T1 sin theta is equal to 50 Newtons, left is equal to right. Up is equal to down. What is in the up? It's T1 cos theta, which will eventually become equal to 60 Newton. So at T1 cos theta will be equal to, they would say T2 is here, there's also T2 equal in opposite reaction, T1 and T2, the T2 in T2. So T1 cos theta will be equal to T2, but this T2 is equal to 60, therefore I can equate this directly to 60 Newtons. So dividing the first and the second equation, the T1 and T1 get cancelled, tan theta is equal to 5 by 6. That's the angle that this rope is going to make with a vertical. So the question is, what is the angle the rope makes with the vertical in equilibrium? So this is the sum. Let's go to next question. 33rd question. They would write it as theta is equal to tan inverse of 5 by 6. Bringing the tan to the other side, it becomes tan inverse. So let's go to example 33, where there is a rope like this and another rope, and this is a wall, and this is a roof, and you have a tension T1, therefore another tension T2 here, and there is a block which is hanging down with a 4 kg weight. A 4 kg weight has to be multiplied by 9.8 or a 10 to convert into 40 Newtons. That will be the downward force acting on it. And can you see that the T1 is slanting? So they have already given this is 60 degree. I would not use Lami's theorem. I would just resolve it as vectors. So then if this is 60, we can write here and write interior alternate angle, this T1 cos 60 and this will be T1 sin 60. Left is equal to right, and so T2 is equal to T1 cos 60. Up is equal to down, and up is T1 sin 60 can be equated to 40 Newton. So you can, the value of all this, you can just substitute what is sin 60, or you can, 40, let's take this equation, T1 into what is sin 60? Sin 60 is root 3 by 2. So T1 therefore is 80 by root 3. T1, you can therefore find T2 is equal to 80 root 3 into cos 60. Cos 60 itself is 1 by 2, so 40 by 2. So 40 by root 2, you can rationalize and write these answers. So you can also multiply and divide by this, then it will become 80 by 3 into root 3. Root 3 is 1.732. Just multiply and check your answers. Use Aurora while doing the sums, and they have given that. They've given T1's answer to be 45.26 Newton and T2's answer to be 22.63 Newton. Make sure you're getting the answer. This is the method in which we do the 34th question. So you have a pendulum which is like this in a moving train, which means the train is moving like this. The pendulum is suspended in the train and the train is moving like this. Obviously, the pendulum goes backward. It has the same acceleration as the acceleration of the train. And they have given that semi-vertical angle is 4 degree. This called semi-vertical angle is 4 degree. You know that there will be an mg which is acting on the bob, and there will be ma which will be a force acting on the leftward direction. The moment you see this, you can do a resultant, which by parallelogram law, you don't need a parallelogram law here because this 4 degree has been given. You do a 4 degree here, do a 4 degree and do tan 4 degree. Tan 4 degree is opposite by adjacent. In opposite, you should draw this parallel vector. This MA can also be drawn here as MA, or this is downward is MG. So it's opposite, which is MA, by downward adjacent, which is MG, is a tan 4 degree, and M and M get cancelled. So acceleration of the bob is tan 4 degree into gravity, which is 9.8 meter per second square. You don't know what is tan 4. If they give you tan 4, yes, we can find the answer. Otherwise, we can't find the answer. We can leave it like that, but you should know the concept. So let's go to 35th question. You have a rope here, which is like this is 60 degree and this is 30 degree, and there is a mass here which is 1 kg weight. 1 kg weight, you should still multiply with 10 and write it as 10 newtons or 9.8. I am not going to use Lami's theorem that Aurora has done here. I would still resolve it only using vectors. This is T1 and this is T2. And therefore, this is the mass. And then I'm going to break it down into vectors. The 30 degree there shows that I can draw and write 30 degree. A T1 cos 30 here. And upward is a T1 sin 30. A 60 degree in here, I'll draw interior alternate angle. And T2 cos 60 here. And a T2 sin 60 here, and I have drawn all this, and left will be equal to right, as simple as that. So then that is done. At T1 cos 30 will be equal to T2 cos 60. So what is cos 30? Cos 30 is root 3 by 2. Cos 60 is 1 by 2. So you get a relation root 3 T1 is equal to T2. You get one value, and up is, this is using left, and left is equal to right. Left vector is equal to right vector. Up vector is equal to down vector. What is up vector? There are two vectors which are getting added. T1 sin 30 plus T2 sin 60 will be equal to 10 newtons. A T1 sin 30. What is sin 30's value? Sin 30 is 1 by 2 plus T2 into sin 60's value is root 3 by 2 is 10 newton. You can substitute T2 as a root 3 T1. T1 by 2 plus root 3 into T1 into root 3 by 2 is 3 T1 by 2. Is totally 3 T1 by 2 is equal to 10. A 4 T1 by 2 is equal to 10. So T1 itself is 5 Newton. Thus you got T1, you can substitute it here back. T2 is equal to root 3 into 5 Newton. 5 root 3 Newton. That will be your T1 and T2. It's so easy for me to find out using vector method. I would never ever use Lami's theorem. Though Lami's theorem can be used, I don't want that. Okay, example 36. Is this rope which is like this, and this is making an angle alpha, this is making an angle beta, and this is a block which is coming down with an mg. As usual, you do this is T1 and this is T2. And if this is alpha, so it will be T1 cos alpha, and there will be also be T1 sin alpha. And this is like this, and so then this is beta, then write it this as beta, and you have T2 cos beta and a T2 sin beta. Now left is equal to right and up is equal to down, and you know what has to be done. T1 cos alpha is equal to T2 cos beta. Left is equal to right. Up is equal to down. T1 sin alpha plus T2 sin beta is equal to mg. That's it. And so then you can substitute, you can write what is T2 from here. T2 is T1 cos alpha by cos beta. Substitute that value here. T1 into sin alpha plus T2 is T1 into cos alpha by cos beta into sin beta is equal to mg. And what is mg here? If you know the mass, if you don't know, you can still write it as m into g. So you can find what is T1 from here by taking out common, and we take LCM, it will be sin alpha cos beta plus cos alpha sin beta is equal to mg. From mathematics you would know that this is sin of alpha plus beta, which is equal to mg. So T1 is equal to mg by sin of alpha plus beta. This is what I am getting. Let's see what is the mistake. I left off this b. Left off this? No, I got it. Let's see what is the mistake I've done here. Up is equal to down. Then substituting this value in T2. You still have when you take LCM, you still have a cos beta down. Yeah, you still have a cos beta down, which I forgot. So there's going to be another T1 taken out. It's mg into cos beta will come. Okay, that's something I forgot. There's still a cos beta even after taking LCM. So that completes this. That's a T1, and on substituting this value of T1 here, you can find the value of T2, and the T2's value they've given it to be mg cos alpha by sin alpha plus beta. Substitute and see. These are the two answers you should get. Let's go to example 37. A uniform rope of length capital L resting on a frictionless horizontal surface is pulled at one end by a force of F. Okay, what is the tension in the rope at a distance small l from the end? So there is a small l from the end. At this point, what is the tension? At this point, what is the tension? This is an entrance question where the capital L is given. You know, total, you have to find the force per, okay, let's see, you know the mass of this entire thing has not been given. What is the tension in this point is the question. The tension in this point will be because when you're pulling it towards the right side, the tension will be contributed only by this mass m dash, not by the whole mass. Okay, when you are pulling it towards the right, the tension is not about the tension at this point means entire mass can be taken into account. But the tension at this point, only the mass which is behind this, especially when moving towards the right, will attribute to the tension. So I need to find this m dash. You know, let's assume capital M to be the mass of the entire length. So you're going to find what is the mass m dash. What is the mass for this, this distance is capital L minus small l. What is the mass pertaining to this portion, or m dash pertaining to this portion, is m into capital L minus small l by capital L, and this will be my m dash, which corresponds to this portion. And so you found the mass with regard to that portion, which is going to attribute for the tension in that point. And tension is always like a force which is mass into acceleration, which is m dash into a. So you know that the total force is F, with which the entire mass m is getting accelerated. So a from this equation is F by capital M, just substituted here. And what is m dash? Is m dash itself is m into capital L minus L by capital L into a itself is F by m, where m and m get cancelled. So it is F into L minus small l by capital L. Okay, so this stands a very, very important sum. I hope you understand this question. So let's go to next question. Next concept is about motion of a connected bodies. Next concept is about motion of connected bodies. You have a pulley and two bodies are connected by means of a rope in the pulley and running over a pulley. So you understand that whenever there's a pulley, it's the same thread which runs over it, and so tension in here will be the same as tension in here. That is something you should understand. Let's consider this block of mass capital M, this is small m, and let's consider that that the capital mg will be acting down and small mg will be acting down. Gravity is going to always pull it down. But you're going to consider that this is going to accelerate like this, then this mass is going to accelerate upward. Something is going to pull it towards like this, then that's going to go up. Everybody knows. So let's take a free body diagram of this. Let's take this diagram alone. Since it's accelerating downward, the downward force capital mg is greater than the tension. That's why it's able to accelerate downward. So capital mg minus tension is equal to capital M into A, the mass into acceleration of this body. This is my equation 1. Let's consider the free body diagram of this. It's going to move up, which means up. T is greater than mg in this case. So T minus mg will be equal to small m into A, and this is my second equation. So once you get this, you can write what is T from both these equations. What is T? mg minus ma is equal to T, and T is equal to ma plus mg. Both of them are small, and you can equate both of these equations because both of them are same tension. Mg minus ma is equal to ma plus mg. You want to find acceleration, move this to that side, bring this to this side. Capital Mg minus small mg is equal to capital M into A plus small m into A, where A can be taken out, capital M plus small m, G can be taken out, capital M minus small m. So acceleration of this body system is capital M minus small m by capital M plus small m into gravity. This is the formula, and they'll ask you this derivation. You must make sure you're able to understand this. So let's go to next question. Example 38. Okay, it has got a 7 kg block. A 7 kg block which has been placed on a frictionless smooth surface. A pull of 15 Newton is applied on the rope attached to this. There is a rope which is attached to this block. The block is of mass 7 kg and the rope is of mass 0.5 kg. And you are going to apply a force in here. And what is the force exerted? Oh, you're going to apply a force here which is 15 Newton. They've given this force. Whenever they give you total force, it's total mass into A. So acceleration is capital F by capital M. What is capital F? The total mass is this plus this, which is 7.5. So total force is 15 Newton by the total mass is 7.5. So then it's accelerating at 2 meter per second square. You know, the entire system is going to accelerate with an acceleration of 2 meter per second square. Now the question is, what is the force exerted by the block on the rope? At this point, what is the tension? What is the tension? What is the force? So when you're moving rightward, only this mass will attribute to tension at this point. The mass is 7 into acceleration is 2. So 14 Newton is the force that will be responsible for the tension at that point. So let's go to next question, the 39th question. So you have a block here which has been placed on the floor. Okay, the mass, this is of 2 kg which rests on the soft horizontal floor. When an iron cylinder of mass 25 kg is placed over this 2 kg block, the floor starts yielding. That is, this will come down, accelerate and come down. Supposing in a room, I am trying to put too many students and putting iron table, the floor is not able to take that load, it will yield. You know that some flyovers are yielding when a big lorry flies over the flyover. They say lorries cannot go in the flyover. There's restrictions, right? So that's called yielding. By yielding. So then the floor yields because, and then the two masses together is accelerating downward. Okay, so then floor yields and the block and the cylinder are accelerating with an acceleration of 0.1 meter per second square. What is the action of the block on the floor before and after? Before it's like mg is equal to normal reaction. So you know that there's an mg which is acting downward, which is 20 Newton, will be equal to normal reaction because floor is not yielding, there is no acceleration, no net force. R is equal to 20 Newtons. In the second case, you know, there is an acceleration and okay, that's the second part of the question. That the force of gravitational attraction on the earth is equal to weight of the block. Okay, so normal reaction I've already found. Okay, so next is they've given acceleration and you have to draw this. You know that there's already m into g acting downward. There is already an m into g which is acting downward, which is the total mass, which is 25 plus 2 is 27 into 10 or 9.8, let's take it as 10. That's the mg which is acting downward. And there is also a normal reaction to this. And since it's accelerating downward, there is a net force which is acting downward. So mg should be greater than r. So mg minus r should be responsible for the total mass to accelerate, which is also 27 into 0.1. So it's 270 minus r is equal to 2.7, and r is equal to 270 minus 2.7, because you know the downward force is greater than the upward force. So mg minus r is equal to the total mass into a. Here in this you have to take the total mass every time. So the value of this is 267.3 Newton. And by third law, the action, they're talking about, they are asking about the reaction. That's what we found. And vertically, okay, by third law, the action of the system on the flow. This is the action of, okay, the question is, what is the action of the block on the floor? You know, the reaction is upward. The action of the block on the floor will be downward. They ask you that word, you should write this to be downward without forgetting, and here also you should write downward. They didn't ask you normal reaction. The action of the block on the floor is equal to normal reaction. You're finding the normal reaction in both the cases. I hope you're clear. So let's go to 40th example. You have a mass m2 and you have a small mass m1, and you're applying a force of F. The first thing you see is F is equal to m1 plus m2 into A, from which you can find A, which is F by m1 plus m2. You know that entire acceleration of this system is this A meter per second square. Once you know your A, they will ask you at the at some point here, what is the tension or what is the force at the point of contact. The blocks are pushed by a force F. If the two blocks are always together in contact, what is the force on the common interface? Yes, the force on the common interface here, normally I will put this mass will be responsible. That's only when you are pulling it like this. You are not pulling it like this, you are pulling it from this place. So this mass is what is going to attribute to the tension at that point. That is what you should understand. So that mass m2 into A, which is F by m1 plus m2, will be the tension at that point, or the force at the interface, F dash. Okay, very, very important sum. And so let's go to next question, which is the 41st question. So then there are masses m1 and m2 and an m3, and all of them are connected by means of a string, and there's a force which is acting. The moment you see that and this frictionless surface, you write F is equal to m1 plus m2 plus m3 into A, and therefore you write what is A is F by m1 plus m2 plus m3. Always this is what you find, the acceleration of this, then acceleration of this, and acceleration of this. The entire system will go in the same acceleration when you pull it on the right side. It makes sense, right? Now they'll ask you, they've already given this force to be 50 Newton. They've given this mass to be 5 kg. They've given this mass to be 10 kg. Given this mass to be 15 kg. You can substitute this value. So 50 by 5 plus 10 is 15. 15 plus 15 is 30. So then you get a 5 by 3 meter per second square to be the acceleration of this entire unit. You know this is 5 by 3 meter per second square. This is also 5 by 3 meter per second square. This is also 5 by 3 meter per second square. Now the question is, what is the question? They're asking us to find T1 and T2 tensions in this thing. You know that there will be a tension T1 like this. There will be a tension T1 like this. There's a tension T2 and there's a tension T2. And you know that this F will be equal to this T2. And by resolving the free body diagram, let's go for, okay, let me make it a little more simpler. Let me take it like this. And you know that this is also T2, this is also T2. Let's take the free body diagram from the left hand side. There is no friction. Normally friction will act like this when you pull towards the right. Tension is on the right side. But there is no friction. And yet the body is going towards the right direction, which is greater, T1. So you know the tension T1 is greater than, there's nothing, minus 0 is equal to mass m1 into A. And m1 is 5 into acceleration is 5 by 3 is 25 by 3 Newton is my T1. I found the T1 using this free body diagram. Because right force minus left force, the frictional force, there's no friction because it's smooth flow. Let's take the next free body diagram here. It's T2 minus, okay, what have they asked? Have they asked, okay, we can take this, we can write T2 minus T1 is equal to M2, which is 10 into 5 by 3, which is A. You already know what is T1 is 25 by 3 is equal to 50 by 3. So T2 therefore is 75 by 3, which is 25 Newton. You can take this free body diagram and do it. You can also take this free body diagram and you can write F minus T2 is equal to M3 into A. You still will get the same value, 50 Newtons, you still get T2 to be the same value of 25 Newtons. You can check, cross verify and see, and this is the way you have to solve this sum. Let's go to example 42. You got a masses which is M1 and M2 and another mass which is M3, and there is a tension T1, there's a tension T2 and there's a tension T3. You know that there is M1 plus M2 plus M3, all of them's gravity acting downward is going to be there. Yeah. So then there is the tension T1, and you know that is this going to be accelerating upward? Let's read the question. 3 masses M1, M2, M3, which was respectively given as 5 kg, a 2 kg and a 3 kg. Calculate the values of T1, T2, T3 and tensions. The whole system is going upward, which means it's going to accelerate upward. When this entire thing, which is going to acceleration of A, this is going to have an acceleration of A, and it's going to have an acceleration of A. This is the total force, and you can take it as T1 is equal to M1 plus M2 plus M3 into A. So A is equal to T1 by M1 plus M2 plus M3. Do you know the acceleration? Have they given the acceleration? Oh, they've given the acceleration to be moving upward with 2 meter per second square. Oh, no need to find the acceleration. The acceleration is given. You can find T1 therefore, which is the topmost force, which is because of all these 3 masses, which is below. T1 is equal to, no, but what about the gravity which is acting downward? So you understand that there is also gravity which is going to pull it down equally, like downward, which is M1 plus M2 plus M3 into G. It's going to go up. The up force is greater than the down force, which is M1 plus M2 plus M3 into G. And the net force is T1 minus M1 plus M2 plus M3 into G will be equal to M1 plus M2 plus M3 into acceleration A. The up force minus the total downward force, which is by all these 3 masses, is equal to acceleration M1 plus M2 plus M3 into A. You can find therefore T1 to be M1 plus M2 plus M3 will be common, and you get A plus G, and you know acceleration they've given to be 2, and A you can take it as 10 or 9.8, and you can add all the masses, which is 5 plus 2, 7, 10, and you can find the tension here. They've given it as 118 newtons. They have taken this as 9.8. You find 10. You find the T1. Once you find T1, then it's easy. You can find T2. For T2, you should take the masses below only to be acting downward, which is M2 plus M3 into G only is acting downward, because T2 is just here, this free body diagram. So it's T2 is greater force minus M2 plus M3 into G is equal to M2 plus M3 into A. So T2 therefore is M2 plus M3 into A plus G. Just add only those 2 masses, which is 5, and A plus G is just 2 plus 9.8, and you get this answer, which is 59 newtons, and that will be T2. To find T3, you should take this free body diagram, where the mass is only of M3 into G, which is acting downward. So what is greater? T3 is greater than M3G, so M3 into G. T3 is responsible for M3 to accelerate upward. So T3 is equal to M3 into A plus G. M3 itself is mass 3, and A plus G itself is 2 plus 9.8, and as usual you can get this answer, it's 34. But very, very important sum. When the whole system is stationary, the acceleration will be 0. Up is equal to down. Then you know that the up for every value of you know the T1, I'll do it in purple color, will be equal to M1 plus M2 plus M3 into G if it's going to be in equilibrium. So you find in that case you can find T1 T1 is equal to m1 plus m2 plus m3 into g. T2 will be attributed because of only m2 and m3 into g, and T3 will be only because of m3 into g. Like that you can find only if the system is in equilibrium or it's not having any acceleration upward. Okay, let's go to next question. Is the 43rd question. A body of mass m. A body of mass m is resting on a table. This is let's say this is m1, then there is m1g which is acting downward, and a normal reaction which is upward. They both will get cancelled here, and it's a smooth frictionless surface also that's running. Rope is running over a pulley, and then there is another block in here of mass m2, and they've given that the system is accelerating like this. Then this is also going to have the same acceleration a, and this m2g is what is acting downward, and there is a tension T, and in this case, in this free body diagram, you understand that m2g has to be greater than the tension T, and so minus T, capital T is equal to m2 into A. m2 into g. So tension, you can just write what is the tension in here, and so m2 into g minus m2 into A is equal to tension T. Okay, so then that is my tension in this, and that's the same tension which will be here also, because it's a pulley which is run, the same rope is runs over the pulley, the tensions have to be the same. And in this case, if we consider the free body diagram, the right force minus the frictional force is 0 should be equal to m1 into acceleration A. Therefore, T1 itself is m1 into A. But this is also tension T and this is also tension T. So okay, let me read the question. A body of mass, they have given this mass to be 10 kg. They have given this mass to be 5 kg. When what acceleration will be provided in the bodies when the nail fixed on the table? You're fixing a nail here and you're removing this nail. So it suddenly starts moving rightward. What will be the tension in the string during the motion of the body? Okay, so then we are going to find the tension in the string, and the only mistake I have done is I took the free body diagram in here and I'm writing m2g minus T is equal to m2 into A. So T itself is m2g minus m2A. Let's take this one left side, got T to be m1 into A, substituting T as m1A here, m2 into G minus m2 into A is equal to m1 into A. Consolidating A together, you get A into m1 plus m2. So A is equal to m2 into G by m1 plus m2. And that is my acceleration that I'm getting. Once you get the acceleration, you can substitute in one of the equations, and thus you can get the tension, or you can even substitute it here. This is even easier. T is equal to m1 into A is m2g by m1 plus m2. Let's multiply those values and see what is the masses. What are the masses you have? A 10 kg and a 5 kg, which is 50 kg into gravity. Let's take it as 10 by a 10 plus 5 is 15. So it's 60 by 15. So I'm getting 4 newtons. The answer is wrong. Okay, let's find the acceleration here. Well, what about this A? What about this A? Oh, this A you should substitute, and A is m2g. Okay, let's find acceleration first. What is m2? The m2 is the second mass, which is 5, into gravity is 10 by m1 plus m2 is taken as 15 in here. So it's 5 3s are 15. 10 by 3 meter per second square is my acceleration. And so then substituting acceleration here, T is equal to m1 mass of the first body is given to be 10 kg into 10 by 3, which is 100 by 3. 100 by 3, 3 3s are 9, 3 3s are 9, 33 newtons approximately, and that's my tension, and that's the same answer has been given in the book, so no problem. I made some mistakes, so make sure that you're finding acceleration and then substituting it here, then you get the right answer. So it's the same tension that's going to be in both the ropes. When the bodies are stopping, this is the second question, the acceleration is 0. In that case, when there is no acceleration, T will be equal to m2 into g. So in second case, m2 itself is 5 into gravity is 10, so 50 Newton, and so that's about it if it's stationary. So let's go to 44th question. So you have a stand here to which the hook is connected, and there is a pulley and a rope is running over it in this direction, and when you're going to apply a force in this direction, this length will decrease, and so then the block in which has been kept here will start moving leftward. These are simple concepts which is common sense. But the invention of the pulley, when there is a force F which it's pulling like this, there will be another force like this. That's the most beautiful thing about the pulley. It will get added as 2F, which will be acting on this block, and we'll be able to push it so easily. The block of mass 100 kg is set in motion by this setup, and the acceleration of the block is given to be 10 centimeter per second square. They've already given the acceleration as 10 centimeter per second, which is nothing but 10 into 10 to the power minus 2 meter per second square, which is 0.1 meter per second square. That's the acceleration with which the block is going to move towards the left. And mass into acceleration of this, which is 100 into 0.1, which will be 10 Newton, will be the force with which it's going to pull leftward, and this 2F is responsible for pulling it. So 2F is equal to 10 Newton, F is equal to 5 Newton, thus force that you have to pull it with will be just 5 Newton. That's the beauty of the invention, about the invention of a pulley. So let's go to 45th question. You have a block which is here and a thread which runs over here to a fixed pulley here which is fixed to the stand, and you have a rope, and there is a movable pulley here, a pulley which is suspended, which can move, and it's connected to a roof here, and there is another block of mass m2 which is connected here, and there is this block which is m1, and it's a frictionless surface. There's no left force in this direction. So you have a tension which is the same in all the ropes. Why? Because they're all connected by means of pulley. So if this is T1, this is also T1, this is also T1, but this will be T2, and equal and opposite T2 will be there. It goes without saying. This is called a movable pulley, and this is a fixed pulley. It's been fixed. Okay, so if this is going to move through a distance of x, this will move through a distance of x, and so individually the pulley will adjust itself, cause an x by 2 and an x by 2 displacement in this. Or therefore we can say if this is going to accelerate by a, this is going to accelerate by an a by 2 and an a by 2, and eventually, the block is going to move only with an a by 2 acceleration, not with the entire acceleration a. This doesn't come down as much as this goes left, because the pulley is there and there are two ropes. So then therefore you understand this is a and this is a by 2 to be the respective acceleration. That's the first step you need to write. And let's take the free body diagram of the left side. In this there's no friction. The right force is greater than the left force. T1 minus 0 is equal to m1 into a. T1 itself is m1 into a, equation number 1. Let's go to free body diagram of this. Let's see, this is going to accelerate downward, you all know. So then therefore m2 into already there is an mg which is actually also acting downward. There is an m2 into g which is also acting downward, and that has to be greater than the two tensions here. So m2g minus 2t1 is equal to m2 into acceleration is a by 2. You can substitute t1 to be here m2g minus 2 into m1 into a is equal to m2 into a by 2. So this can get pulled that side. m2 into g is equal to m2 into a by 2 plus 2 into m1 into a. So a is here m2 by 2 plus 2 m1 is equal to m2 into g. So a itself is what you can find, it's m2 into g by, when you take an LCM and this comes down, it will be m2 plus 4 m1 and a 2 goes up, and you get something like this to be your acceleration, which is that's the a, and but you want a by 2 only, no? You want acceleration of the second block, it's a by 2, then bring this down and write this as the answer. Such a beautiful question. Let's go to next question, which is the 46th question. The 46th question is the two identical masses of capital M are connected by means of a string. Imagine it to be connected by means of some massless metal string of length L. You're going to apply a downward force exactly in the midpoint. The wire will get bent like this, and this will become L by 2 and an L by 2. But these two masses therefore will come closer. this comes closer, this length will get decreased, this will be L by 2 and L by 2, that will be the changed position. And so then if you're going to consider this angle to be theta, two identical point masses, each of mass capital M connected to one another by massless string capital L, a constant force of F is applied at the midpoint downward if the L at some instantaneous distance L. So this becomes L by 2 and L by 2 between the two masses. What will be the acceleration of the two masses? You have to consider that the acceleration is happening leftward, not downward. So let's break it down into component. There will obviously be tension in the string. This is tension T and this is also tension T, which gets broken down into this is theta, this will also be a theta, so this is T cos theta and this will be a T sin theta. Similarly, this will also be a theta and so then this is T cos theta and there will be a T sin theta, and the left will cancel out with the right, and so there is no, we can't say that. Let's see, you have to put this T cos theta in here to the mass and this T cos theta in here to this mass, and the upward force has to be put here as T sin theta, another as T sin theta instead of doing it in here. Once you do this, you know there's a force, downward force, which is acting here. The left force will cancel out with the down force will cancel out with the up force, because there's no downward acceleration. The acceleration is only happening towards each other. The two masses are going to come towards each other. So the vertical component gets cancelled out. F will get cancelled out with a 2t sin theta. So it gets no net force on the vertical direction. But horizontally, if you see, there is an acceleration. And so what can I say? Let's take only one mass, and can I say T cos theta will be equal to capital M into A, which is responsible for the acceleration of only this. So what is cos theta? From this triangle, can you find what is cos theta? Cos theta is, one second, hold on, somebody has come. So sorry guys, I had to break this. So T1, but we want to find what is cos theta. Cos theta, can we write it as adjacent, which is L by 2, by hypotenuse, which is root of L by, adjacent we don't know. Yeah, adjacent is L by 2 and the hypotenuse is capital L by 2. Okay, don't cancel this off. What you do is you write F is equal to upward force, which is 2t sin theta, and write this as your first equation. Then you take T cos theta. You know, T cos theta, one of the T cos theta is equal to capital M into A. This is your second equation. Divide the first equation by the second equation. 2t sin theta by a T cos theta is equal to F by capital M into A. T and T get cancelled. 2 tan theta is equal to F by capital M into A. You write what is tan theta from this equation. What is tan theta is opposite by adjacent. The opposite by adjacent. Adjacent is L by 2. Opposite is hypotenuse square minus base square. So root of opposite is root of L by 2 the whole square minus small l by 2 the whole square. Opposite by adjacent is just L by 2. Is equal to F by capital M into A, and so then when you solve this, you will get what is acceleration. Okay, so it's 2 into root of L square by 4 minus L square by 4 by an L by 2, and no, the root is only for the is opposite by adjacent. So this is only for this, not for the denominator. Not for the root is only for not for the denominator. So is root of capital L square minus small l square by 2 will come, and an L by 2 is there. 2 and 2 will get cancelled. Is 2 into root of L square minus small l square by small l. You get something like this, and is equal to F by MA. So cross multiply and find the value of A from this. And that's all. Okay, so that's about this sum. So beautiful. That's very difficult question. This is not a textbook. This is not your school level sums. These are entrance kind of questions. So next is this inclined plane sum, where they have given this angle to be 30 degree, this angle to be 60 degree, and there is a block here and this mass is 50 kg. There's another block here whose mass is 30 kg, and there's a pulley here which is fixed, and the rope is coming down like this. You should know that in this, you're going to assume that the 50 kg is going to pull it in this direction with an acceleration a. This is also going to go with an acceleration a. Then we are assuming, we don't know what's happening because this angle also is a determining factor. So you know that there always the mg will be acting down, so 500 Newton is acting downward. When this is 30, this will also be 30 always, and so this 500 into cos 30, and this will be 500 into sin 30, and thus you are able to break this down. The normal reaction is always like this, and similarly for this the normal reaction is like this, and you will have an mg which is down, which is 300 Newton, which is going to get, this is 60 degrees, so it's 30 cos 60, 300 cos 60, and this will be 300 sin 60. And since this there will be a tension here and there's a tension here, and both of which will be the same because it's running over a pulley. Since this, let's take a free body diagram in this direction. Since it's accelerating upward like that, you know that t is greater than 300 into sin 60. T minus 300 into sin 60 will be irresponsible for the 30 grams to accelerate. 30 grams to accelerate. So then what is sin 60? T minus 300 into sin 60 is root 3 by 2 is 150 root 3 is equal to 30 into A. Thus you get one equation. Let's take the free body diagram for this. You know that the downward 500 sin 30 is much more than T. So 500 sin 30 minus tension is responsible for that mass 50 to accelerate. Okay, so this is what it is. You know two equations. You know what is sin 30? What is sin 30? Sin 30 is 1 by 2. So it's 250 minus capital T is equal to 50 into A, and this is my second equation. You can equate both these tensions. You can find what is T from here, what is T from here, and thus get the acceleration, and you can substitute it in one of the equations to get the tension. I hope you're clear. Please try this sum. And I was teaching you about the friction, which will be continued in the next video.